All right, so we really need to know how to do this for what we're gonna do today again. So let's find one positive and one negative angle that are coterminal to this. Not as much this one as this one. You better know how to do that one. All right. So am I gonna do it the long way just to review everything again? All right. So find one positive and one negative angle that are coterminal to 210. Start here. 210. We're gonna go positive 210. So go up. This is 90. 180. So we got to go another 30 more. So it's going to be right here. All right. So this is 210. There's an infinite amount of answers here for a positive. Find one positive. So we can go keep going and then end up at that same spot. So I added another revolution to it. This is one revolution. So I'm adding 360 to that 210. So this will be 570. Another one would be, if I continue on, 360. If I wanted to get another one. What's that, 930? Is it? So that's going another revolution, and then there's an infinite amount of answers. So that's one of them. The other one is to just go negative and then get to it. So one way to do this is just to the given angle, just add 360 and gives you that. To the given angle, subtract 360. That'll give you the answer is negative 150. Okay, so sketch 210 degrees in standard position and draw its reference triangle. I already did it here. Sketch 210. So yeah, we got 210 being right here. Reference triangle. With my first period class, I already saw when I look at the homework, I see people doing this, drawing this. And the only reason why we're doing reference triangles is because we need to, for the next lesson, just know how to do the reference triangles. That's definitely not it. So I don't know what to tell you other than if you land up on this spot, say if it is here, it's gonna be a bow tie. One of the four parts of a bow tie. It's gotta be that. If you end up over here somewhere, it's gonna be one part of the bow tie. It's gonna be this. If you end up somewhere over here, it's gonna be this part of the bow tie. If you end up anywhere over here, it's gonna be this part of the bow tie. This is called a bow tie, a butterfly. Yes. You get no choice. This is not an art class. Oh, but I like this. No. It is mathematical. For what we're going to do, it's either this one, this one, this one, or this one. That's it. All right? Okay, so let's go to the lesson for today. One of the sides of the triangle got to be on the x-axis. All right, let's go. Lesson 9B. Okay, go ahead and copy that down. Get a ruler. Yeah, the best way to learn math is to build on your prior knowledge. Whatever prior knowledge you have. And some of the prior knowledge is so basic, and that's where I try to tap on to the most basic of basic knowledge of geometry. So, this right here is a square where one of the sides is going to be the x-axis, and the other side here is one of the other sides the y-axis. Okay, so we got the square there against this. What is special about a square? Anybody from geometry? What is special about a square? All the angles are how many degrees? All these angles are 90 degrees. So all these angles will be 90 degrees. And we denote that by putting a little square here, and putting a little square here, and putting a little square here, and putting a little square here. And that's going to say that it is, each one of those angles is 90 degrees. Okay. Another thing I'm going to tell you. Okay, tell me what else is special about a square? Anybody? What is special about a square? Something else? All the sides are equal length. They're the same length, or they're equal. If this is x, that's x, that's x, that's x. If this is 1, that's 1, that's 1, that's 1. And so let's say this is 1, and this is 1, and that is 1, and that is 1. Now, okay, what I'm going to do is this, because this is trigonometry. So it deals with triangles. So let me break this into two triangles like this square. So now I'm gonna get, what is this angle? It should be like the whole class, just so you guys got a calculator. What's 90 divided by 2? 45. So now this is a 45 90 triangle. That's a 45 90 triangle. So we got a 45 90 triangle. All right, so we got this. Going over it again. If that is 1, if it is a square, that's 1. That is 1. And then 90 90 90 90, half it, 45 90 triangle. Okay, here's the next question. My last question. It's solving the triangle, no? If this is 90, this is 45, this is 45. So I got all the angles figured out. I got the side here figured out. We got the side that figured out. I just need to figure out what that is, and I would have solved the triangle. What is the length from here of this, it's called hypotenuse, of this long side, or this hypotenuse? How long is this? Somebody said 2. It's not right. At least you didn't say 45, like your mother class. Oh, 45. Not even close. This one, how the heck is that going to be 45? What else? What else could it be? Nobody? No other. Okay, because I just want to teach and finish the lesson and not spend too much time on it. Are we going to just sit around and be like, I don't get it, I don't know? You could actually Google it, and you could do a lot of different things, but let's do math. Could we do a Pythagorean theorem? Have you guys ever heard of that Pythagorean theorem? Yeah? How does that go? What is it? A squared plus B squared equals C squared? Okay, so you do remember that from geometry. All right, we will figure it out, what that is. So let's call this A, and let's call it B. They're interchangeable because A and B are the same. The one that is not interchangeable is this hypotenuse is always by itself. So let's plug in. So this is 1 squared. B is 1 squared. Question mark. Leave it at C squared. What is 1 squared? 1. 1 times 1 is 1. Plus 1 is equal to C squared. 1 plus 1 is what? 2. And it's equal to C squared. Square rooted? Yes? And it's, if you really want to know exactly not exactly. And the approximation to it is 1.41 on forever. It's called an irrational number. So about 1.41, if somebody would have said 1.4, 1.5, I would be like, okay, you got a good, yeah, probably, no. So this is 1, this is 1. If this is, to scale, 1.5, 1.4, yeah, it looks like. It's not no 45. Yes? Okay. Good. The next one is going to be the Illuminati triangle. The Illuminati triangle, I just call it Illuminati, but it's it's an equilateral, equiangular triangle. So we got an equilateral triangle. So if it's equiangular, equal angles, how much is each one of them equal to? And somebody's saying 60 because it is 180 divided by 3. 180 triangle is equal to 180 degrees, add up all the angles. 180 divided by 3 is 60. Is this 60? 60? 60. Okay. Now, let's say that this particular one, I measured it, and actually is double this, is 2. Let's say that I measured it a length of 2. This is equal lateral, is 2, 2, 2, 2. All right. This is what I'm going to do now. I am going to cut it in half and make 2 right triangles out of it. 2 right triangles. Okay? So everything makes sense. Everything is true. So if I cut this into 2 right triangles, how much is this angle here? 30. Yes or no? 60 divided by 2 is 30. This is 30. Okay? So I am making a 30, 60, 90 triangle here. So then that would make this what? This is what? 1. Why is it 1? Again, it's all deductive reason. If this is 2 and I cut it in half, wouldn't it be 1? Yes or no? So this is 1. So we got this. Look, we'll do it again. If that is 2, that is 2, that is 2. 60, 60, 60. 30 over there at the top. This becomes 1 here. Now, here's my next question. What is this? How long is this? Quickly do the Pythagorean theorem. And you did that a lot. I know you did. If you did anything in geometry, you did a lot of that. A squared plus B squared equals C squared. Work it out. Go. Give me the answer. What is it? Because this class is not about doing Pythagorean theorem. This class is about sine, cosine, and tangent. I will tell you that this is square root of 3. You do all the math, it's square root of 3. A squared plus B squared equals C squared. And I'm telling you, this is the hypotenuse, got to be by itself. 2 squared equals, this is A, this is 1 squared, plus the question mark, I guess, squared. So this is 4 equal 1 plus question mark squared, minus the 1, square root of 3. It's going to be square root of 3. Okay, square root of 3. Here we go. Okay, you should know that. Memorize that. Let's just do this one more time. This is where people just... do you guys know what opposite means? Opposite. Over there means opposite. Let me just kind of go over that a lot here. You are always standing, when it comes to this kind of stuff, you're always standing at the origin. This is you right here. This is you. There's only 3 sides to a triangle. That's why it's called a triangle. 3 sides. You can't mess this up. That's definitely the hypotenuse. I think you shouldn't. That's the hypotenuse. Opposite of this, opposite of 90 is hypotenuse. That's for sure. Where people mess up is to know which one is opposite. Which one is opposite? The 1 or the 1? I'm messing with you. Is it the one or the one? That one. Opposite is on the other side over there. This is opposite. This is called right next to. It's called in English is adjacent. Right next to. Your foot is on top of it. Same thing if you get yourself, put yourself over there, it will be the same kind of scenario. All right, continue. Sine, here we go to the sine, cosines, and tangents. Sine of an angle is the sine of wherever angle you're standing at. Here we're going to stand at the 45-degree angle. Sine of this angle, 45 degrees. Sine of a 45 degrees. I will keep talking about, and I guess I'll bring it up, that some lady about 5 years ago, the more time passes, the more it's, she would, she's out in what, in LA, somewhere over there in LA, she was trying to teach geometry to her students, and she came in dressed, she would always come in dressed as a Native American and all with everything all dressed up. And she would come and then do dance and do all that, and she would be saying "Sokatoa," and she started dancing "Sokatoa," and then some kid videoed her, took a video, which nowadays people video everything, and then it got on the internet, and then she got fired and whatever. She was trying at least. Not that I'm gonna like. But at least she wasn't just sitting around doing nothing. I don't know. I don't know what the heck she's thinking, but she was trying. Sokatoa. So she's over there dancing Sokatoa. And she said, well, she would be saying she's out of a job, maybe I should have. Oh, hypotenuse. Sokatoa adjacent hypotenuse. Sokatoa. OPP. Adjacent. All right. It's just a mnemonic. I have really bad memory. That helps me a lot. But people are like, stop saying that. Just tell me how to do it. That's how you're going to do it. Sine means what? It's, okay, here's another one that people are like, it's a ratio. What does ratio mean? Let's see. What does a ratio mean? Anybody, what's a ratio mean? What's ratio? Let me just give you one example for the class in this class. The ratio of teacher to student. There is one teacher, the ratio. Figure out the ratio is one teacher. I guess that's me. And you're going to spell it, to 27 students in this particular class. That's called a ratio. I could have done a ratio for when I went to college and I took a introduction math class. There would be one teacher for 300 students in a class. That's called a ratio. You do ratios for also what is that? Cooking class. You watch the cooking class. The ratio of sugar to this, the ratio of this to that. They go like this. They go the ratio of five tablespoons of this per 10 something of that you put in. It's a ratio. Not that complicated if you know the numbers. The ratio of the sine, where sine is the ratio of the opposite side length over the hypotenuse side length of this particular triangle. And that's going to be sine is OPP. Oh, I forgot. Which one is OPP? Is it this one or the one? This is called opposite. So that's going to be what? 1 over the hypotenuse is what? Hypotenuse is what? Come on. One person. Root 2? Okay, we continue on why mathematics is so confusing. People are, is math so confusing? So, why is it confusing? Because what? Back also, in addition, what? 70 years ago, 60 years ago, there would be calculators that were twice, they were big calculators, would do not even a fraction of what this little calculator does, because we were so, technology wasn't advanced. So they would always ask about rationalizing this. What does it mean, rationalizing? They didn't like to have a radical at the bottom of a fraction. So how do you rationalize this? This is how you rationalize it. You multiply the top by the top and the bottom by square root of 2. Whatever numbers that, square root of 2 divided by square root of 2 is 1. You're not doing nothing to it. And then you're going to get 1 times root 2 is root 2. At the bottom, you're going to get root 2 times root 2 is root 4. And what is root 4? What's the square root of 4? The square root, no, here's another one people make. Square root of 4 is equal to 2. The square root of 4 is not square root of 2. Just don't do that. A lot of people do that. Square root of 4, square root, no. Square root of 4 is 2. 2 times 2 is 4. Okay, so the answer to this at the end of the day is going to be like this. Sine of 45 degrees, opposite is 1 over root 2. 1 over root 2 is root 2 over 2. Cosine of 45. Cosine of 45. I don't want to do any work. Any genius can tell me what it is cosine of 45 going to be? Huh? What's cosine of 45 going to be? Square root of 2 over 2. How? You're like, but how? I don't get it. So, I'm going to bring that lady in. She's like, nah, shut up, work. Adjacent over hypotenuse. Adjacent, cosine is adjacent over hypotenuse. What is adjacent? 1 over root 2, which is root 2 over 2. Tangent 45. To OA. Yes, tangent O over A. What is it? What's O over A? I need one person to say it so I can just continue on with teaching this. What's O over A? 1. Opposite over adjacent is 1 divided by 1 is 1. Yep. Get yourself from standing here, walk yourself over here, and you're looking at another triangle. That triangle over there. Now you're doing sine of what angle? 60. Sine of 60 degrees. Well, the sides of a sine of 60, the side of a triangle that has 30, 60, 90 degree angles is going to be different, of course, than 45, 45, 90. So, let me go ahead and put these OPP. Now, this is OPP, this is hypotenuse, and this is adjacent. So, what is sine of 60 degrees? Sine of 60 is root 3 over 2. Cosine of 60. What's cosine of 60? 1 over 2. Tangent. What's tangent gonna be? So got to root 3 over 1, which, yeah, somebody again, if another class, one student was root 3 over 1. What is root 3 over 1 reduced to? Root 3. The answer is root 3. You can always put under any number. You can do pi divided by 1. Oh, I'm confused. What's pi divided by 1? It's pi. Okay, now here we go. We're gonna put everything together from what we did yesterday to today. And that's what it is. Here we go. What is the exact value of cosine 135? Let's go, problem 1. What is the exact value of 135, cosine 135 degrees? So what you needed to practice, here's another one about the state of education at the moment. Am I going to get controversial here? I might not have to put it on because then I don't want to put this on my website. With all this breaking down the wall, with all this poor kids, give them too much homework. There's a national thing about poor. We gotta look over kids' self. I don't know. Their, what is it called? Their social emotional stuff and all this kind of stuff. Man, it was when I was in school. In any case. Where am I going with that? Okay, yeah, that's where I'm going with this. So I give you homework so you can practice enough, just enough, so you can continue to build on the mathematics. Some people can just watch what I do and they're like, I get it. I don't need to practice. I just understand it. Very few people are like that. You're lucky, I guess you could do that. But a good amount of people need to do a little practice. That's why I give you these worksheets. Go home and do a little practice and then come back. All right. So what is the exact value of cosine 135? This is what you were supposed to have done. You went home. I need to get to 135 degrees. Am I going to go up to get to 135 degrees or am I going to go down? And if it doesn't come out quickly, just up. Angles, positive angles go up, negative angles go down. That was the lesson from yesterday. So now, I'm going to go up 90. How much more do I have to go? Okay, I'm turning it. I'm all right now, just at 90. How much more do I have to go? 45. Thank you. 45. So you need to know how to draw this, and this is 135. That's one standard or one thing you need to know how to do. Once we got there, all that 135 degrees is telling you where to turn that thing to. So we've turned it there. That's all I needed that for. I'm not paying attention to that anymore. I'm just doing this because I don't need it anymore. That tells me where to go. Now I'm going to draw my reference triangle. The next step is to draw a reference triangle. And what are people going to do again? I'm telling you, go home, and if you practice it wrong, you're going to go like this again. You go like that. You're like, but I practiced. I didn't get it. Bow tie. Bow tie. You're not gonna get the bow tie doing it like that. Bow tie. You're gonna get this little thing here, and you're not. That's not it. That's not one of them. So we're gonna do it correctly, and put the reference triangle here. Okay. Now, really, what I need to know is, I'm looking at this triangle here. What is this angle here? That's where you get a little bit of thinking. What is this angle here? 45 is correct. And why? You're like, how? Why? Well, look. If this is 90, and then I win another 45, because 90 plus 45 is that 135, the leftover here better be 45. 45, 90. This is 45. Oh, so that makes this 45. This makes this 45. 45, 90 triangle. 45, 90 triangle. And we go back to what I had done over here, where we had done that 45. It's a square. If it's a square, this is 1, this is 1, this is root 2. So if I transfer it to flipping it to the other side, that is this here. It would be this one, where this is 1, is over here 1, this is 1. If you go to the left, it'll be negative, because it's not on the positive, but this is positive, and this is positive for the y. And the hypotenuse is always positive, and that one is root 2. That's what I'm going to do over here. What the heck did I have? It's a 45, 90. That's going to be 1, root 2. This is negative. Okay. So now, let's go. What is the definition of cosine again? What was it? What was the definition of cosine? Cosine is a ratio of the adjacent over the hypotenuse. So what over what is the answer? What is it? It would be what? Isn't this adjacent right here? It would be negative 1 over root 2. But 60, 70 years ago, we had no calculators and we had this problem. And I don't know why it's still a problem. The answer should be what? Negative root 2 over 2. It's still, the whole number is negative. Some people get confused, like, why isn't it? Well, the whole number is negative and it will stay negative. All right, let's go problem number 2. We're almost done here. Let's practice here number 2. We got number 3 and we'll be done for today. Problem number 2. I got a problem, dude. Right now I'm so missed because talking Spanish with my stupid friends for the Unified messed up my check. They don't even know how to do taxes. I gotta go tomorrow. I gotta go talk to them. They're taking all kinds of money from me. Stupid. I have to go talk to them. It's gonna be on this. So we gotta go. Okay, the only thing that you need this for. Are we gonna go up or are we gonna go down? Down. Down to 40. You only need that to go down this much, then all the way to negative 90, negative 180, and then how much more? This is the way. How much more do I have to go? Negative 60, isn't it? Negative 60, 60. So it'll be 60. So something like standing up a little more, because this is going to be 60. And sine is what? Let's go over it. Okay. All right. Let's get these numbers. Look. You have to just remember opposites. Opposites are the best, and that's the way I remember. 63. Opposite of 63. Remember that number 63, but it's radical 3. 30, opposite of 30, 30 what? 31, 31. Opposite of 30, this is 30. 1, but it's negative because it's on the left. 90, opposite of 90. 92, 92. You need to get those numbers. And once you get those numbers, then you can do the sign is what? What sign? What ratio sign? I'm gonna bring that lady. That comes down. Soka sign. So. What is it? What's opposite? You're like, I don't know what opposite is. This is your foot is adjacent, so it better be down because that's happening. Root 3 over 2? Root 3 over 2? Yes. Tangent 120. I have to go tomorrow, not today, because of the So we got to go to 120. Are we going to go up or down? We're going to up. So it's going to go to 90. How much more do I got to go? 30. So here, look. This is 30, but the reference triangle is what? This one, 60. That's the way to look at it. So this 60 and opposite, it's the same as this right here. So 60, radical 3. 31, but it's negative, and 2. And tangent, what's the definition of tangent? Opposite over adjacent, which is going to be O over A, which is going to be what? Root 3 over negative 1, which is going to be negative root 3. Negative root 3. And we're done.